Let's begin. We have limit as x approaches 2 of x to the fifth minus 32 over x minus 2. The first step is to plug in x equals 2, and we get 0 over 0. I want to manipulate the top equation so that I can have an x minus 2 outside and some other factor next to it. So for this one, I'm going to use long division. I'm going to have my x minus 2 outside, and then I'm going to have x to the fifth minus 32. For this, I'm going to compare the highest exponents, so x and x to the fifth. So what do I need to multiply x to get x to the fifth? That's just going to be x to the fourth. So then I'm going to multiply x to the fourth with x and negative 2. And then I'm going to subtract this. The x to the fifths cancel. I get 2x to the fourth minus 32. Next, I look at x and 2x to the fourth. I need to multiply x by 2x cubed to get to 2x to the fourth. So I have 2x to the fourth minus 4x cubed. The 2x to the fourth cancel. I'm left with 4x cubed minus 32. Next, I look at x and 4x cubed. I need to multiply x by 4x squared. So I get 4x cubed minus 8x squared. 4x cubes cancel, and I get 8x squared minus 32. I look at x and 8x squared. Well, I need to multiply x by 8x. So when I do that, I get 8x squared minus 16x. I subtract, and I get 16x minus 32. And I see that x and 16x, right? So I need to multiply x by 16 to get to 16x. So I'm going to add 16 here. And in doing so, when I multiply 16 by x minus 2, I end up getting 16x minus 32, and the remainder is 0. So that means I can rewrite x to the fifth minus 32 over x minus 2 as x to the fourth plus 2x cubed plus 4x squared plus 8x plus 16. And now if I let x equals 2, if I plug in x equals 2 into this equation, I get 2 to the fourth plus 2 times 2 cubed plus 4 times 2 squared plus 8 times 2 plus 16. So that is 16 plus 16 plus 16, and then 2 squared is 4 times 4 is 16. So they're all going to be 16s. We have 1, 2, 3, 4, 5 copies of 16. That's going to give us 80. So our limit turns out to be 80. Okay, let's try another one. What if we have limit as x approaches 2 of square root x squared plus 5 minus 3. Sorry, the minus 3 is outside of the square root over x squared minus 2x. I plug in 2 and I end up getting 0 over 0. So for this one, I'm going to multiply top and bottom by the conjugate of the top. So the conjugate of the top is going to be square root x squared plus 5, and then outside of the square root is plus 3. We're going to do that top and bottom. That's always usually the case. when you have a square root. Okay. Now, the top is a difference of two squares. If you have a minus b times a plus b, you'll have a squared, which is just x squared plus 5, minus b squared is 9. The bottom, I'm going to leave it as is for the square root, but I'm going to factor out an x from x squared minus 2x. So if I pull out an x, I have x minus 2. And then in parentheses, I'm going to have x squared plus 5, and then plus 3. At the top, I have 5 minus 9, so that simplifies to x squared minus 4. And then the bottom is the same. I can factor out the x squared minus 4 as x minus 2 times x plus 2. And then the bottom is again the same. Now the x minus 2's will cancel, and I can plug in x equals 2 now. So we'll have 2 plus 2 at the top, and then 2 times, well, 2 squared plus 5 is 9, square root of 9 is 3, plus 3 is 6. This is 4 over 12, which is 1 over 3. So my limit is 1/3. Next, we're given a very long, complicated limit. We have limit as x approaches 1 of x to the 4th plus 3x cubed minus 13x squared minus 27x plus 36 all over x squared plus 3x minus 4. So just by looking at this, this looks very intimidating. So you should always test, if you plug in 1, what do you get? Turns out you get 0 over 0. Unfortunately, there's no nice, easy way to do this. So what we can do is do long division here. So let's take the inside to be, should be x to the 4th plus 3x cubed minus 13x squared minus 27x plus 36. And on the outside, we're going to have the denominator. So it'll be x squared plus 3x minus 4. I'm only going to be looking at the terms of the biggest exponent. So that's x squared and x to the 4th. So I need to multiply x squared by x squared to get x to the 4th. And now I'm going to distribute the x squared to x squared, 3x, and negative 4. So I get x to the 4th plus 3x cubed minus 4x squared. The x to the 4th and the 3x cubed terms cancel. I have negative 13x squared minus negative 4x squared. So that's really adding 4x squared. I have negative 9x squared minus 27x plus 36. And now I compare x squared with negative 9x squared. I'm going to need to multiply by negative 9. So I have negative 9x squared, and then negative 9 plus 3x is negative 27x. And then negative 4 times negative 9 is 36. And that leaves me with a remainder of 0. So what this means is this whole expression that we started with can be simplified to x squared minus 9. So this limit turns into the limit as x approaches 1 of x squared minus 9. I can now plug in x equals 1 to get negative 8 as my limit. Alright, let's try another one. I have limit as x approaches negative 3 of 2 minus square root x squared minus 5 over x plus 3. If I plug in negative 3, I end up getting 0 over 0. So I'm just going to multiply the top and the bottom by the conjugate of the top. So that will just be 2 plus square root x squared minus 5. And then same thing with the bottom. I have a difference of 2 squares at the top, so that will just be 4 minus the quantity x squared minus 5 over x plus 3 times the quantity 2 plus square root x squared minus 5. At the top I have 4 minus negative 5, so 4 minus negative 5. That's going to give me a positive 9. So it's limited as x approaches 3, and I'm just going to rewrite it as x squared plus 9. No, I'm sorry, that's not right. It's negative x squared plus 9. And that's over x plus 3 times 2 plus square root x squared minus 5. I can factor out the top as negative x plus 3. And then, let's see, x plus 3. And so I have x plus 3 at the bottom times 2 plus square root x squared minus 5. The x plus 3's are going to cancel. And let's see. If I were to plug in 3 now, I get 0 over 0. So that's not good. Or actually, never mind. We do not get that. So let's try this again. So if I plug in 3, at the top I get negative 3 plus 3, and the bottom is 2 plus 3 squared minus 5. Negative 3 plus 3 is 0, and then I have 2 plus 9 minus 5 is root 4, so it's 0 over 4, and my limit is 0. Yeah, this problem was definitely tricky, because I thought this positive here was a negative, and that would have given us 0 over 0, but thankfully it was only a positive. Okay. Let's try a similar one, and we'll finish up with this. Let's see. Given limit as x approaches 4 of negative, oh sorry, not negative. We have positive 4 minus x over 5 minus square root x squared plus 9. If I plug in 4, I get 0 over 0. So I'm just going to multiply the top and the bottom by the conjugate. So it'll be 5 plus square root x squared plus 9. And at the top, I'm just going to leave it as is. I'm not going to distribute. So it's going to be 4 minus x, and then 5 plus square root x squared plus 9. And the bottom is a difference of 2 squares. So we have 5 squared minus square root x squared plus 9 squared. And I'm going to rewrite the top as it is. And then the bottom is going to be simplified. So I have 25 minus 9, which is 16. So it's really 16 minus x squared. And that can be factored further. So let's see what that is. That's 4 minus x times 4 plus x. The 4 minus x is going to cancel. And now if I plug in x equals 4, I get 5 plus square root 4 squared plus 9 over 4 plus 4. let's see, 4 squared is 16 plus 9 is 25. Square root of 25 is 5. 5 plus 5 is 10 over 4 plus 4. So my answer is 5 over 4.